Hi there. Here is an example of how we can use RAG, Retrieval Augmented Generation, as well as one-shot and n-shot learning to train a large language model to understand a database schema and produce complex bespoke reports in response not to technical SQL, but instead to natural language requests from business users like risk managers. The fact that large language models are language in, language out means that they can be put into loops. This creates the ability of LLMs to mimic human reasoning and solve problems in a series of steps. React prompting, an example of which is shown on your screen, is a clever way to stimulate this reasoning behavior. This React prompt allows LLMs to break down complex problems, like database query generation, into a series of simple steps. Imagine the Lehman Brothers default, or the UK gilt crisis. In such scenarios, risk managers need rapid access to critical information stored across databases. In crisis situations, it is unlikely that the standard reports in business systems tie in with what the crisis request is. As a result, the standard reports often fail to deliver the specific, detailed insights required during these crises. This is where our LLM application comes in. By teaching an LLM the database structure, and by giving it examples of the correct SQL query for a natural language input, it is able to learn the schema and then build complex queries in response to detailed, precise natural language requests. Let's dive into the database structure using DB Browser for SQLite. Here, we see key tables like trade, instrument, and specific instrument tables. These tables store crucial trading data that our app will query. Traditional reporting methods rely heavily on drop-down lists to modify SQL clauses. While effective, this approach can be time-consuming and cumbersome. Our application uses advanced schema generation, enabling more dynamic interaction. We've implemented Retrieval Augmented Generation, RAG, and one-shot learning to enhance our LLM's understanding of the database schema. Here's an example of our n-shot learning data. This technique trains the LLM using pairs of natural language statements and their corresponding SQL queries. For instance, to find the total notional value of all swaps in each currency. The app translates a simple query into the correct SQL. The more examples of this input and query pairs you give, the better. Aim for a diverse set of queries and make sure that there is a good mix of simple and complex queries that cover all of the relationships in the database. Our app empowers business users to generate custom reports with natural language queries. For example, consider the query: provide a list of trade and counterparty details for swap shun trades where the counterparty type is asset manager and the strike rate is in the top 12% of the strike rates of all trades. The application processes this request and generates precise SQL to retrieve the data, making complex financial data analysis accessible to all users. You can see in the panel on the lower right of the screen the agentic behavior of the trained LLM as it figures out the right SQL query in response to the user request. As you can see, the results are displayed instantly, showcasing the app's ability to handle sophisticated queries with ease. Really complex queries can be handled, and results get back to the business users. I'd argue here that the use case should be trust but verify. As well as producing the results, the app provides the SQL query. This can be given to the DB team to analyze and verify that the results are accurate given the query.
This is Richard Walker signing off. Hopefully this video gives you some additional ideas on how to train large language models and use agentic behavior for additional AI applications at your firm.